In this video, we're looking at how can we use trigonometric formulas, the type of formulas that you find on the back of the Regents exams on the reference sheet. Now, this problem says, find the tangent of 2 theta if the cosine of theta is equal to negative 2 radical 5 over 5, and theta is in the second quadrant. Okay, good. So the first step for problems like these is we have to find a useful formula. So to find a useful formula, you take a look at your reference sheet, which is on the back of your Regents exam, and we are looking for formulas that include what it is we're trying to find. In this case, we're trying to find a formula that talks about the tangent of 2 times the angle. So I'm looking here on the reference sheet, and I notice that right here there is a formula that talks about the tangent of 2 times the angle. It says the tangent of 2a is equal to 2 times the tangent of a all over 1 minus tangent squared a. Good. So I'm going to write down that formula here so it's easier for you to see. It says that the tangent of 2a is equal to 2 times the tangent of a over 1 minus tangent squared a. Here is the formula we want to use. So we have found a useful formula. Why is it that this is a useful formula? Because you see, we want to find the tangent of 2 times an angle, and this formula involves the tangent of 2 times an angle. Now that we have found a useful formula, we're on to step 2. Step 2 is to be very clear about what we know and what we need. So what is it that we know? Well, we know that the cosine of theta is negative 2 radical 5 over 5. That's a very useful thing to know. So the cosine of theta is negative 2 radical 5 over 5. We also know that this angle is in the second quadrant, and that will be important. So we're here in quadrant 2. What are we going to need? Well, what I mean by what it is that we need is you look at your formula and you say, what am I going to have to know if I'm going to use this formula? To use this formula, we need to know the tangent of a so we can use it on top and square it down here on the bottom. If we just knew the tangent of a, we could use this formula and then we could have our answer. So the challenge now is to go from what we know to what we need. And as is often the case, the way you go from what we know to what we need is by using a trigonometric identity. In this case, since I know a cosine, I'm going to use that Pythagorean identity that has a cosine in it. So I'm going to use the one that says that the cosine squared theta plus the sine squared theta is equal to 1. So let's substitute in what we know. After all, trigonometry is one big exercise in substitution. So I'm going to replace this cosine with a negative 2 radical 5 over 5. So here this is negative 2 radical 5 over 5, and we have to square that, plus sine squared theta is equal to 1. When we square this, we square all the parts here. So negative 2 squared becomes a 4. Radical 5 squared becomes 5. 5 squared is 5 times 5. See how I did not multiply it together? Of course, we know that that's a 25, but by not multiplying it together, it makes it more obvious that we can just cancel something out there, right? So I will now just cancel that out. So this is actually 4 over 5, plus sine squared theta equals 1. I'm going to subtract 4/5 from both sides now. So this becomes sine squared theta is equal to 1 minus 4/5. To get a common denominator, we take that denominator and we multiply 5 over 5. So this is saying that sine squared theta is 5 over 5 minus 4 over 5. 5 over 5 minus 4 over 5 is just 1 over 5. So this is now going to give us the following. It's going to give us sine squared theta is equal to 1/5. We need to undo that square. The way we do that is by taking the square root of both sides. So we get sine of theta is plus or minus the square root of 1/5, which is plus or minus the square root of 1 over the square root of 5. The square root of 1 is 1, so this is plus or minus 1 over the square root of 5. So now we have the sine of theta is plus or minus 1 over the square root of 5. We don't like this radical in the denominator, so we will rationalize that. Radical 5 over radical 5. This becomes plus or minus radical 5 over 5. Now what about this plus or minus? Should we use the plus or should we use the minus? To decide that, let's go back to these useful fact here. You see, this is an angle in quadrant 2. It says right here, if you remember, that this angle is in the second quadrant. And since we're in the second quadrant, what does that tell us? Well, it tells us that here we are in the second quadrant, and that's right there. Since we're talking about sines, well, you see, in the second quadrant, all the y's are positive, which means that the sines are all positive, so we should go with the positive value. And we know that the sine of theta is radical 5 over 5. Now, why is that useful? Well, the reason that that's useful is we need to know the tangent of A. And now we know the cosine and we know the sine. How can we use the sine and the cosine to get the tangent? Well, let's see. The tangent of theta is equal to the sine of theta over the cosine of theta. And we know both of these now. So we can get the tangent, which is what we need. So the tangent of theta is equal to, here is our radical 5 over 5 that we just got. So I'm making that substitution. This is radical 5 over 5 over the cosine of theta. The cosine of theta is negative 2 radical 5 over 5. What do we do when we are dividing two fractions like this? You're absolutely right if you said that we should multiply by the reciprocal. So this is the tangent of theta is equal to radical 5 over 5 times 5 over negative 2 radical 5, right? Take this and flipped it over. Some very nice things happen. See how this 5 on top and this 5 down below, those guys cancel out. This radical 5 on top and this radical 5 on the bottom cancels out. We end up with the tangent of theta is equal to, what's left on top is a 1. What's left on the bottom is this negative 2. And so the tangent of theta is equal to 1 over negative 2. Now we have what we need. And so now we are ready for step 3. And this is the final step. Step 3, once we have found a formula, once we have used what we know to get what we need, we're ready to substitute and simplify. So, to substitute, what are we substituting into? We're substituting into this formula. The tangent of 2a is equal to 2 times the tangent of a over 1 minus tangent squared a. We're substituting in there. What are we substituting in? We're substituting in this value for the tangent that we just came up with. We know that the tangent of theta is equal to 1 over negative 2. Remember when we got that? We got that right there. And so we're going to just put this into this formula and simplify. So we get that this is the tangent of 2a, 2 theta, is equal to 2. Now instead of tangent of a here, I'm going to put, what is this value that we just came up with? Well, that's a 1 over negative 2 over 1 minus that value squared, which is 1 over negative 2 squared. So we've done the substituting. Right here we've done the substituting, and now it's ready to do the simplifying. So we'll simplify what we have here. 2 times 1 over negative 2. That's 2 times 1, which is 2 over negative 2. 2 over negative 2 is negative 1 over, we can simplify this denominator here. This is 1 over negative 2 squared. This becomes 1 over negative 2 squared becomes 1 over 4. And 1 minus 1/4, this is like 4 over 4. So 4 minus 1 is 3/4. So on the bottom down here we end up with 3/4. So this is negative 1 over 3/4. When you're dividing by a fraction, you're multiplying by the reciprocal. So this is 1 times 4 over 3. Negative 1 times 4 over 3. So the final answer is the tangent of 2 theta is equal to negative 4 over 3. And that is the final answer.